Hey guys, my name's Tom Shiflet. I am indie developer under the name Lama Game Company, and I teach on an online platform called Outschool, where I teach game development classes as well as just kind of general computer science classes. And today I want to go through a real quick and simple first-person controller in Unity. It's one of the most useful kind of skills and scripts to have in your back pocket. Now, the one that we're going to build today is very bare bones. This is what I usually put in to a new project just to get my character moving very quickly, to do some testing and prototyping and stuff like that. And you would probably want to expand on this and do some cleanup on it to make it kind of production ready. But what I have here is just a simple world, flat platform, as well as some stairs and some little walls up here. I've already dropped a capsule in here to be my player. And so first off, we will get this set up for to be ready for our code. So the first thing I'm going to do on my player here is add in a Rigidbody. And on my Rigidbody, I'm going to go ahead and expand out the constraint section and freeze the rotation on all three axes. We don't want external forces to be causing our player to rotate. We don't want to freeze the position because we will be using the Rigidbody in order to actually push the player around. Again, this is a really simple prototype kind of first-person controller. And so we're going to be directly modifying the velocity, not using forces to apply to it, which takes a lot more tweaking and balancing and stuff like that. But we don't want, like the big thing is we don't want the player falling over based on the fact that it is a capsule collider on here, so it has a round bottom, and so the player can actually fall over if we don't freeze those rotations. The next thing we want to do is put our camera into our player. So we're just going to drag our main camera, drop it onto our player, so it's now a child, and then we'll set our position to 0, 0, 0, and then we really just want to drag that camera up towards the top. What I normally do is put it at about 0.85, so that way it is close to the top. This is a default capsule. I didn't change the scale on it at all, so that means that it is 2 meters from top to bottom. And so that puts our eye line up near the top. So we've got about a 6 foot tall, 2 meter tall person with the sight line being right up near the top. Now you want to make sure that that camera is not outside of the geometry up here, because we don't want to see the geometry. As long as we're inside, then we're not going to see the actual geometry here. Also, I prefer on my first-person controllers to turn off the shadow on the capsule, because it looks kind of strange to have a capsule shadow from a first-person perspective. If I'm doing a more advanced game, then I'll put an animated model in here and have that animate and set that animation to shadows only. So, or set that model to be shadows only. That way it doesn't draw the geometry. I don't see my hands moving or anything like that. I only see the shadow being cast on that. So now we have our player basically set up in order to handle this. Now, for the Rigidbody, we could come in and set the mass to be whatever we wanted if we're really going to be using physics collisions and things like that. But again, for this, we're just going to leave mass, drag, everything at 1. I mean, everything at default values. So now I'm going to create a script. And the way that we're going to do this, I have to be organized. I can't do that. So I'm going to create a scripts folder. The way we're going to do this is in 2 different scripts. And so the first one that we'll do is our player move script. I am suddenly unable to type. Okay, so player move will handle just the basics of moving our actual player. And so we're going to expose a couple of variables here. And so we're going to say private float speed is equal to 5. And we'll go ahead and serialize another field here that is our sprint modifier. And so this is how quickly will we move when we're sprinting as a multiplier. And so this means we're going to move 2 times faster than whatever our speed is set to. Now, since we're going to be modifying this directly on the rigid body, we're going to want to do this in our fixed update. And first thing we'll do is just go grab the input. And so we'll just say float forward, let's call it Y. So this is our vertical axis. So on a gamepad or on the keyboard, W and S are the up and down arrows. So we'll do input.getAxis vertical, use that default axis that's set up, and then float x will be equal to our input.getAxis for the horizontal axis. If you're ever unsure of what axes are created by default, you can always jump into your edit and project settings, and in the input manager we can expand out the axes, and here we have the horizontal, which is default left and right keys, also the A and D. Vertical is up and down arrows as well as the S and W, and then there's duplicates of these down here in this lower section that is mapped to joystick axis for the x-axis and joystick axis for the vertical axis. Now, when you're getting the axis, the spelling, capitalization, everything has to be identical to what's here. So if you're ever unsure, or if you're just not good at typing, select that, copy it, jump back over to your code, and paste it in. That was the wrong one. Okay, so now we have these axes. These values are from -1 to 1. And so we can use that to our advantage in multiplication. So you multiply any positive number by a negative number, and that is going to turn it into a negative. When we're dealing with vector 3's, it's going to take our forward vector multiplied by a -1 if they're pushing down, either D or down arrow, or holding back on the thumbstick axis, and that's going to give us a negative value. So forward times a -1 is going to be backwards. And so we're just going to set up a very simple vector 3 here. Before we do that, let's do this. Let's go ahead and create a reference to our rigid body. And so this will be a private rigid body. I typically just call mine RB. So in my start function, I'll say RB is equal to get component for our rigid body. And then now we can come in down here and create this vector 3. We'll call it move. It's going to be a new vector 3. We're going to zero out our x. Now for the y, we want to go ahead and grab the rigid body's y velocity, because we don't want to reset that. Since gravity is a acceleration force, we want to continue, keep that y value so our player continues to accelerate down. And so we can just say that this is equal to our rb.velocity.y, and then we'll go ahead and zero out our z-axis. And then we'll say move plus equals our transform.forward times our speed times, let's not worry about sprint yet. So we'll just say that's our forward times our speed. Oh, forgot the most important part. We got to multiply by our y, by our input. And then we'll do the same thing for our transform.right times our speed times our x input, so that horizontal input. So transform.right, if our input is left, then this will be a -1, and so it will, the opposite of right will be left. And then we just say, hey, our rigid body's velocity is equal to this move vector that we just created. And so let's save that, let it compile, jump back over to Unity, and then we'll drop this onto our player and give it a test run. And so we should be able to move both left and right, forwards and back at this point. Obviously no mouse look or anything yet, but we can move in all directions. Let's go ahead and get our mouse controls set up before we implement the sprint. That way we can kind of alter the direction that we're going. I'm going to go and turn my guy so he's facing the stuff. So, all right. So for the mouse controls, we're going to do a different script, and this script will actually be attached to our camera. And so our player move is moving the actual player model. Our mouse look will do two things. Number one, it will move our move our camera up and down around the x-axis. And so that red x-axis, we're rotating around that to go up and down. We're going to want to cap it so it can't go more than straight up or more than straight down. We don't want the player to be able to flip all the way over and turn upside down. And then the second thing it's going to do, if we move our mouse left and right, then we're not going to rotate the camera, we're going to rotate the player, because we want to change the direction that the player's facing. Since our movement is based on that transformed out forward, the player's local forward axis or local z-axis, we're going to actually rotate the player around. And so let's create a new script here. We'll call it mouse look. And in this, again, we're going to create a couple of variables here. We'll expose a few of them. And so let's serialize a field for a private float, and we'll just call it sensitivity. And I'm just going to default that to 1. Since it's exposed in the editor, you'll be able to make changes to it quickly and easily in Unity. And then we also are going to need a private float for our X rotation. And we'll just default that to 0. And then the last thing we'll need is access to the actual player model. And so again, we'll expose this, and this will be a private, not float, it will be a game object, and we'll just call it player. And so this will be the actual player model that we'll be rotating with our left-right movement. And on this, since we are not directly modifying the Rigidbody or anything, we can make these changes in our update. If you're fairly new to Unity, anytime you're directly making changes to the Rigidbody, you want to do that in the fixed update, which is when the physics updates occur, which is by default 50 times per second. Our update runs every frame, and so this might be 500, 600 times per second, depending on the complexity of your scene and stuff. So, all right, first off, we're going to go grab the input. So we're going to say float mouse x is equal to our input get axis. And again, we can look and see what those axes are in our project settings. Our horizontal movement is just mouse space x, capital M, capital X, and then mouse y is our vertical. And so our mouse x is going to be get input mouse space x, and then float mouse y is equal to input get axis for our mouse y. And so let's handle the left and right rotation. This is where we're actually rotating the player model. And so we're just going to say player.transform.rotate. And then for rotate, we need to basically give it a vector 3 for the rotation. And the easiest way to think about this is if you take the vector that we're rotating around and multiply it by the amount. And so we're rotating this around vector 3.up, which is our vertical axis, times that mouse x, and then we want to multiply this by our sensitivity. And so if we save this and we jump back over into Unity. I didn't put that script on there, so select our camera. We need to drop the mouse look on here, and we need to assign this variable to our player, so we can just drag player and drop it into that slot. And so now, as we move our mouse left and right, we're able to look left and right. Now, obviously, we still have the mouse cursor on the screen, which is highly annoying. So let's jump back over. Now let's handle the up and down. And so the up and down we're going to handle slightly differently because we're going to keep track of it in this X rotation variable here, and then just assign that rotation to the X axis. And so we're going to say X rotation minus equals our mouse Y times our sensitivity. Now, if you've done a little bit in Unity and you may be thinking, hey, why are we not multiplying by time.delta time to scale by our frame rate? The nice thing is the mouse input axis is already scaled by the frame rate because it is the amount of change since the last frame. And so we do not want to multiply any of the mouse inputs by our delta time. So, all right, so now we've altered this X rotation. Now we need to make sure that they're not rotating more than 90 degrees up, 90 degrees down. And so we're just going to simply say X rotation is equal to mathf.clamp. And so what clamp does is we can give it a value and then a minimum and a maximum. And it will ensure that it stays between those values. And so our actual value is whatever X rotation is equal to at that point. Our minimum will be -90 and maximum will be +90. And you could also do this as a series of if statements where you say, hey, if X rotation is less than -90, then X rotation is equal to 90 or -90. But this is just a quicker, easier way to do it. Now we need to plug this into our rotation of the camera. And the camera being a child of our player, we need to make sure that that rotation is relative to the player. It's not an absolute rotation. It is a local rotation of how it sits in relation to the player. And so we're going to say transform dot local rotation. And rotation is handled in quaternions, but we're dealing with vector 3s, so we can say quaternion dot Euler, and then give it the vector 3, which will be our X rotation for the X axis. And then we're going to keep it at 0 on both the Y and the Z. So that way the Y rotation lines up kind of left, right where we're looking with wherever the player is looking. And then the Z rotation would be the roll, how the camera rolls left and right. And obviously we want that level. So we'll set that to 0. And so now we can save this, jump back over into Unity, and give it a test run. And so now we're able to look up, down, left, right. We still have the very annoying mouse cursor out there, but we have the beginnings of a first-person controller. So let's take care of the mouse real quick. So we'll just do this in our mouse look. Typically in a more full-featured game, you would want to handle the mouse, like locking the mouse and unlocking the mouse in a game manager or something like that. But we're just going to say cursor.visible equals false, and then cursor.lockState is equal to our cursor lock mode dot locked. And so this will force our cursor to be not visible and then lock it to the center of the screen. So if we save that, give it another test run. You do, in order for it to actually lock the mouse, you have to click in your game window, and that will lock it in here. And so now we are able to move around in more traditional first-person status. Since we are using rigid bodies, you shouldn't have issues with clipping completely through walls. Depending on the size of your player, you may, like, if I come into this wall at just the right angle, there might be some clipping into it. But again, I can kind of set the size of my player collider or the exact position of the camera in order to minimize that. All right, so now let's go back and handle our sprint. And so we can do this in a couple of ways. Let's look at our project settings, input manager, and take a look. We don't really have anything in here right now that makes sense to use for a sprint key. Typically sprint keys are your left shift. Fire 3 is actually already mapped to our left shift or our mouse 2, which is like clicking down on the mouse wheel typically with most mouses. And it's also going to be joystick button number 2. So let's rename, since this is already mapped to our left shift, let's rename this to be sprint. And then we'll go ahead and rename it down here as well. And then we'll jump back over to our player move. And we're going to need another variable up here. And this one does not need to be exposed. This will be a private float. And we'll just call it sprint. And we'll set it equal to 1. And then in our fixed update, before we modify our move vector, we're going to want to check and see if they're sprinting so that we can adjust the speed here. And so we'll just keep our inputs together. And so we'll say if input.getButton. So we want to be sure and use getButton, not getButtonDown, because getButton will be, this is, every time it checks it, it's looking to see, hey, is this button held down right now at this moment? Returns true every frame or every physics frame that this button is held down. Get button down will only return true one time, one frame, and then it will be false until they let off the button and push the button down again. And so we're going to use get button, and the name of our button is sprint. And if they are holding down this button, then we're going to set our sprint variable equal to our sprint mod variable, which again is right now set to 2. And so this is, they're going to be running twice as fast. But if they're not holding down the button, we'll have an else in here and say sprint is equal to 1. And then we just need to add this multiplier into these lines here. And as a math teacher as well, I have to say here, order doesn't matter if everything is multiplied. And so we can just tack this onto the end, multiply by our sprint value. So we go ahead and save this, jump back over, let's get rid of our project settings. And so now we're moving, and then we push down the shift, and as long as anytime we're holding down the shift key, then we are sprinting. Okay, so there's the very beginning basics of a first-person controller. Now let's add in a jump real quick. And so back to our player move. So jump, we're not directly modifying the rigid body. We'll be adding a force to the rigid body, but we're not directly modifying the value. So this we can do inside of our update function. But let's expose a variable here for how hard the force is or how strong the force is for our jump. And so we'll serialize the field. This will be a private float, and we'll call it jump force. And let's set it equal to 500 to start off with. We have a mass of 1. This is one of those numbers you kind of have to play around with. If you increase the mass of your player, obviously you'll have to increase the mass of your, or the strength of your jump force. If you change gravity, which we'll do here in a second, then you may again have to modify this. Since it is exposed, you can do it on the player game object in the editor. And then again, let's jump back over here, see if we already have a jump button set up. And it just so happens we do. It is mapped to the spacebar, which is good. And on gamepads, it is assigned to joystick button 3. And so we can just use that jump. So we're going to say if input.get button down. And so for this one, we only want to catch it the first frame that it's true. And this is our jump button. Then we're just going to say Rigidbody or rb.add force. And very similar to when we're rotating something, we think of this in terms of what axis and multiplied by what strength. So transform.up times our jump force. And so let's save that. Jump back over and give it a little test. See if we're jumping too high or not high enough. Now for me, by default, this feels floaty. It feels very floaty, mainly because of scale. You know, this guy's jumping, this guy's 6 feet tall. These walls are 5 meters tall, and he's able to jump up on top of them. So if I were an NBA player, I would be jumping over the backboard. And so sense of scale is off, but it's a game, right? So we want the player to be able to jump. So what we can do in here is come into our project settings and physics. And this top line is our gravity, which is negative 9.81 meters per second, which is the force of gravity here on Earth. But I'm going to increase that up to about negative 20. And so now when I do it, gravity will pull me back down faster. But obviously I'm not jumping as high. And so I can come in and change that jump force to be something a little higher, say 800. And so that feels better. I'm still able to jump up on top of these walls, but I do fall faster. I come back down. It's less floaty feeling. So, you know, those are numbers that you'll want to play with, depending on what kind of game you're making and how you want it to feel. But the one issue that we have here is that our player can simply jump forever. And so if you keep hitting the space bar, he's just going to keep jumping. And so let's put in a real quick check to see if we're on the ground. And there's a bunch of ways to do this. Probably the simplest is to do a ray cast, where we shoot a ray straight down and see if we're on the ground. And so let's do this before we do the jump. And so to do a raycast, we first need to create a variable to hold the information from the raycast, which we're not actually going to use in this example, but this is a raycast hit. We'll just call it hit. And then we'll say if, because our raycast will return a true or false as to whether it hits something, if physics.raycast, and a bunch of ways to do a raycast. In our case, what we want to do is specify where we're starting the raycast, what direction it's going. We need to give it the variable to hold the information, and then tell it how far to shoot the ray. And so where we're starting the ray is just our transform.position, which is the middle of our player. And so we need to think about that in terms of the distance. We need to shoot slightly more than what the bottom of the player is. Our direction will be straight down for the player. And so that's going to be, we can do negative transform.up, which will be straight down. For the information of where we're holding all the information, we have to specify out. So it outputs the information into this variable. And then our distance, since our player is 2 meters high, we need to shoot slightly more than 1 meter. And so let's do like 1.1 F. And so this raycast will return true if it hits something, false if it doesn't. And you don't have to worry about it hitting the player, because a raycast will never hit any object that it starts inside of. And so if this is true, then we need to do something. the easiest way to do this is before we do the raycast, we'll just say bool is grounded is equal to false. So we default this to false, and if our raycast does hit something, then we set this back to true. And then when we're checking the key press for jump, we'll just add in and is grounded. So they have to be grounded when they push the jump button in order to actually jump. So if we save this, jump back over into Unity, and give it a test, I can no longer jump repeatedly. I have to be on the ground in order for it to allow me to jump. And so again, this is a really simple first-person controller. This is by no means full-featured. It's a prototype version to get in quickly. What I like to do is I keep a folder of scripts where I save stuff. I, can drag and drop them in. These are two scripts that as soon as I start a project, I'll drag these in, set up my player model, put the scripts on it. I have to remember to assign the player here. But this lets me get a really simple first-person controller up really quickly so that I can move around in my game world. And then you can take this and build on it substantially to add in the features that you want, customize it exactly how you want, all of those things. So I hope this helped. If it did help, hit that like button, give me a subscribe, and I'll see you on the next one.